hi there, this is day 2 of our lesson. So I want to make sure you have the sheet we already did. This was Wednesday's lesson, 9:16, so you're going to use the same exact sheet, our target 3 solving equations. So we have taken the notes up until we just did the one solution ones and some practice. So now we're going to go on and see what some other ones look like. So we're at example 2 for today, and we'll finish example 3 as well. So remember, let's just review our steps. We always look for distributive property. That's right here. And then we look for combining like terms. That's in our green right here. The next part is we have to move the variables. We said the variables to one side of the equation, and we have addition or subtraction. We have to use that the whole entire thing. So if it's positive, we subtract it to bring it over. If it's negative, we add it. And then we're basically at a 2-step equation. You then undo the addition and subtraction. That's the number by itself. Add that on there, although we're pros at this, we know that. And then we undo the multiplication or division. That's the number attached to the variable. So if I'm ever going too fast, you can pause it to write it down, but because my videos can only be so long, I talk a little bit faster in here. So rewatch segments if you're a little confused, or just pause as we go along if you need to get some things down or let it sink in. All right, so I'm scrolling down. We're at example 2. So I'm going to do what I always do. I like to draw my line in because I think of this as 2 separate problems. On one side over here, I'm going to look for, on my green side, I'm going to look for combining like terms, distributive property, any of those, getting rid of those first. I don't see any of that. But what I look right away, I see I can take the variable term over to the other side. So I'm going to take this negative 4x to the other side because we have to move all variables to one side, and we want to line them up. So this negative 7 will stay. I'm going to drop it down, and my equal sign. And then this 3 over here is going to stay. So what I would do is the opposite of minus 4x is I'm going to have plus 4x. And I'm going to have plus 4x. I make sure to line up my x terms. Minus 4x and plus 4x cancel out. If I put negative 4 plus 4 in my calculator, I get 0. So those actually cancel out too because I end up with 3 plus 0 and negative 7 plus 0. So what happens is I end up with 3 equals negative 7. So this is where we get into different types of problems. We don't always have one solution. If it's true, does 3 equals negative 7? No. So we call this no solution. Oops. Solution, or NS if you want to abbreviate to. And I'll show you a trick later when I look at it, how I would know if that's what we're going to have or not. So let's try another one. Putting my line in. Now, there's no distributive property over here or combine like terms. There's no distributive property here or combining like terms. So now I'm ready to do my new step. I'm going to take this term, I like to take my x term or my variable term to the left side. I like my variables to be over there because in the end I want it to say x equals. So the opposite of plus 3x is going to be minus 3x, minus 3x. So what happens here is 3 minus 3, they cancel over here. 3 minus 3x, so if I have 3x and I take 3x away, I have 0 x's. So those actually cancel too. I'm left with no variables. I'm left with negative 5 equals 7. Is that true? No. So it's no solution. So that's the second type of problem you might see. There is no x equals here, but that's how I like to see it if we do have one answer. So that's an example there. So let's look at the next one. Let's go to 3. So sometimes you will see decimals and you will see fractions, and that's okay. So We're going to look at adding a few more steps into it, but still, we're going to always do the same thing. This is a problem on the red side. This is an equation or a problem on the right side. So I'm going to look at the left side, the red side. Is there any distributive property? Nope. Any combining like terms? Nope. So I can leave that alone for now. I'm going to go to my blue side. Is there any distributive property? Oh, yes, I see. Oops, let me move that away. I see that there is 4 times 3 halves. So you can put 4 times 3 divided by 2, or you can use the fraction bar. So this is a positive 4, and then we would divide it, we would times it by 3 divided by 2. That's how you can also put it in your calculator. And you end up with 6 of the x's. Next, we're going to distribute again. 4 times a positive 1 is positive 4. So I did the distributive property. I'm going to just drop this down here. 6x plus 4 and my equal sign. I didn't use the other side. So from here, I can look at the problem and I can see right away these are identical. They match. They're the exact same thing. So I could go through and solve it. I can do the work. And what I'm going to end up with is 4 equals 4. But remember, when they're identical or they match, we call that infinite. You don't really need to go any further. You had to do the distributive property to see that this actually matches the other side, but if they match, it's called infinite solutions. And we're done. You don't need to actually solve anymore, because what that means is no matter what number you pick, I could pick 3 through 3 million, and every single number is going to work if I plug it in that equation. Let's look at D. So I have here, I'm going to draw on my line. So again, I'm thinking of 2 separate problems. I got my red side, and I got my blue side. So over here on my red side, I want to look for distributive property. And I do see it, because that's what we look for first. So a fourth times 8x, and I end up with 2x. And then I have a fourth times negative 12. We have to be very, very careful. So if it goes in there, it's negative 3. And then I'm going to drop my other side down, equals, and then this is my blue side, 2x minus 3. I didn't do anything with it yet. Right here, when I look at both sides, I notice they actually match. This says 2x minus 3. This says 2x minus 3. They have to match exactly. So if they are a match, we don't need to do any more work. It's infinite solutions, meaning any number you pick, I'm just going to abbreviate, it can go in there and it will be a solution. So those are the other 2 types that we are learning about, because before we were just doing the one solution. Okay, so I moved to the next page, which are story problems. We always put word or story problems into whatever we're learning in math, because they can be applied to real world things. So we're going to learn to write them. Again, it's going to look like what we've been solving. We're going to have 2 equations, like equation A and equation B, and you're going to set them equal to each other, and we're going to solve, and then what we're going to do is that's going to answer the question of whatever the story problem is. So let's look at the first example. It says, one movie club, it should say movie club, charges a $100 membership fee and $10 for each movie. So if you recall, back a couple weeks ago, we talked about we have a formula for setting up equations when they're 2-step. We end up with something up here times our variable. This is what changes. So we see per, each, every, words like that. And then we either add or subtract it. It's usually adding, but we have to read to make sure. And then another number, which is a 1 time, fee, amount, deposit, something like that. And then equal sign, and here's where it gets different, is we are going to set it equal to a whole nother equation. So we're going to have two different things we're always comparing. Movie Club A, Movie Club B, iTunes to Napster, Verizon to Samsung. So there'll always be two things. So you would just have another equation, plus, that could be a minus, something. And then what we do is we use the steps we learned on Wednesday, where we end up solving an equation with variables on both sides. So we're going to look at this first one together, and then we'll just do some practice on our own after that, because they'll be set up for you for the first day. So this first one, Movie Club A, I'm going to say there's a $100 fee. That's my one-time amount. So I'm going to put that here, something X, and then equals. So this is A, and it says $10 for each movie. So I know that see the word each, that's the one that goes next to the variable. So next, I know I have another club. So this is my second one. So instead of a total here, which we learned to put the total, now we're learning to put the second equation. Another club has no membership fee. It looks like we're going to have something X plus no membership fee. We can put plus 0, or we can just have nothing there, because plus 0 is nothing. So it's up to you, because I kind of teach you a formula, but sometimes there is not a one-time fee. But the movies are 15 each. So we're going to write and then solve it. So this is how we write it. We set the two equations, and if this helps, I'm just going to keep this as a placeholder, the plus 0. I like to have it there. You don't have to, but it helps me. There's no fee. So then now we can go through our steps. Two separate equations, right? This one, which is red, this one, which is blue. So no distributive property on either side. No combined like terms on either side. So now we're to our new step. We are going to take our variable term to the left side. So I'm going to take this positive 15x and I'm going to move it over here to the left, because I like my answer at the end to say x equals. So this is minus 15x, and it cancels minus 15x. So I end up with, and I'm going to rewrite it, 10 minus 15x, that's a negative 5x, plus 100 equals, and then I still have my 0 over here. If I didn't write the 0, I could use 0 as a placeholder. Now I have a two-step equation. That's it. So I get rid of my term that's by itself, plus 100, so I do minus 100. Oops. Sorry. Minus 100. Okay. And then I'm just going to put my work over there. It becomes negative, and then this becomes minus 100. It's negative 5x equals, I'm going to move this because it's too squished. Negative 5x is what I have left over here. See? That canceled, and I have equals 0 minus 100 equals negative 100. So then, last step, divide by negative 5, divide by negative 5. So I cross that out, and I get x equals, 5 goes in there, positive 20 times. So that is when the two equations would be equal, is after you rented 20 movies. So that's how we set up an equation from a story problem. It's the same thing that we've learned before with two-step. You just have two equations. So the story problem will tell you about two of them. And then you solve using our brand new step of moving the variable turnover by adding and subtracting. So that's the lesson for today. And then we'll basically be reviewing the next few days and practicing, because we'll have a quiz next week.